Welcome back to section 3.3, lesson 1. Here we're going to look at the formula for volume of a cone. Now let us remind ourselves the formula for volume of a cylinder. It is the area of the base times the height, which is pi r squared h. Now let's consider a cone that has the same radius and height as cylinder, as shown in the diagram below. If I were to take one of these cones and fill it up with water and then dump it into cylinder, it would be about this high. So then if I repeated that process again, be about this high. And if I did it once more, it would be filled to the top. It would take 3 of these cones to equal one of those cylinders. So that means the cone is about 1/3 the size of a cylinder. So now that we know the formula for volume of a cylinder is pi r squared h, then we can just divide that by 3 to determine the formula for volume of a cone. So let's write that out. So it'll be V equals 1/3 pi r squared h. And you can also write that as pi r squared h divided by 3. So example 1 says, how much ice cream can the following cone hold? So we're essentially looking for the capacity, how much is inside. In this case, the capacity is going to be the same as the volume. So let's write out our formula. Now looking at the diagram, I see that they gave us the diameter of the cone. So we're going to have to divide that by 2 to determine the radius. So that is 26 millimeters. So let's plug in the radius to be 26. So we have pi times 26 squared, and the height is 85. And then we divide all of that by 3. So now putting that in the calculator, I get 60,172.0 millimeters cubed. So let's write that the cone can hold 60,172.0 cubic millimeters of ice cream. Now example 2. Thomas calculated the volume of the cone below to be 10 cubic inches. So let me fill that in. Volume is 10 cubic inches. And then stated that the volume of the cylinder must be 10 times 3, which is 30 cubic inches. Now where did he go wrong? Well, the relationship that exists between cones and cylinders is only true if they have the same radius and they have the same height, which is clearly not true here. So that's where Thomas went wrong. That relationship don't always hold true. So let's make note that the relationship between volumes of cones and cylinders is only true if the radius and height is the same.